All right, so yeah, I'm recording now. This is what we left off with last day, and I wrote this down last day as well. So this will be on your notes yesterday and your notes, of course, today. So I'll just leave this up for a minute. It's kind of this naming, you can choose the common name or the systematic. The IUPAC name as well, because typically we are naming by IUPAC. The only difference is in modern IUPAC, you see like a little difference here, and we've been using systematic. So, because you'll see these are the same, this is good, this would be the systematic name. So typically I would stick with the common name or the systematic name for these crazy groups. It will, and again, you're not going to see a whole lot of these in this course. I might throw one or two on a test, for example, but most of our substituents will be quite straightforward. Okay, so what's coming up next? I have a couple of examples and then, okay, this is good. So I have a couple of examples here. And then we're going to talk about halo substituents. Like what if we put, instead of like a methyl group, what if we put like a chlorine or bromine? And that's really easy to do. And then I'll check the time and we might end with reactions. One little spoiler that I'll mention is there's not actually a large group of reactions for alkanes, especially that we need to know. Alkanes don't tend to be as reactive as alkenes or alkynes. So when we get into chapter 3, you'll see a lot more reactions with alkenes and alkynes. And that's where a lot of like your polymers would come from as well, like alkenes, double bonds forming polymers. So these are just some more examples of naming these fancy groups. So here we're going with the old name, not the systematic name. So, okay, here, let's break this down. I have cyclohexane because it has 6 carbons. Now here, I have a crazy looking group. So there's 2 ways you can approach this. Okay, so you don't count this carbon here, but I look at this group and I have 1, 2, 3 carbons, and on the first one, I have a methyl group. So systematically, you could call this 1-methylpropyl. You can use brackets here if you wish. You typically only need brackets if there is more than one number in front. But honestly, we learned that this is a secondary butyl group. We call this sec-butyl. It's sec-butyl because we have that methyl group. This is an isomer of butyl or isomer of butane. And we have that methyl group sticking off the inside carbon, not the second carbon, the innermost carbon, and it's a secondary carbon. So we would call this, excuse me, sec-butyl. So the name, nice and easy. You could call this 1-sec-butyl cyclohexane, but just like in math class, we don't technically need the 1. So you could call this 1-sec-butyl cyclohexane. That sounds hard to say. Or you could just call it sec-butyl. You don't need the 1. Yeah, I think it's good news too. Okay, so let's go into the next one. Now this one's a little bit, I like this example. So let's look at this one. It says that it's octane, so let's make sure I don't have any spelling mistakes or a typo. So 1, 2, 3, 4, 5, 6, 7, 8. Now there's a problem here because if I number it this way, I get the number 5. Let's try numbering it backwards. Well, for me, it's backwards. I'm a left to right person. So 1, 2, 3. That's much better. We get the number 4. Okay, so this is octane for sure. On the 4th carbon, now remember, we do not count this carbon for my group here. Notice that this group is a propane or propyl substituent. I only have 1, 2, 3 carbons. And for propane or propyl groups, there's only 2 isomers. Well, I guess you could argue there's only one isomer. So here I have propyl. I'm going to do that again because my pen just hates me. So 1, 2, 3. But what I could do is make the isomer isopropyl, where it looks like this. So I have a carbon here, and then a carbon and a carbon sticking off of it. I still have 3 carbons. Excuse me. Sorry, swallowed something wrong. This is in your notes, by the way. So this is not a butyl group. This is a propyl group. And because propyl groups only have one isomer, we don't worry about secondary, tertiary. We just call it isopropyl. So this would be called our isopropyl group. So the name for this is Y and then L, my bad. The name for this would just be isopropyl octane. But because this doesn't, it's not a ring, it's a chain, you need to tell me which carbon does this propyl group stick off from. It could stick off from the 3rd carbon or the 4th carbon. So I would call this 4 isopropyl. And some of you might be wondering, well, wait a minute, where's the number here? Well, just remember, in a ring, where the group is always number 1. So I don't need the 1 there, but you can put the 1 there if you want to. It's completely up to you. If I was going to name this guy systematically, so this is the name up above, I would still include the 4, but I would use brackets, and this is called methyl and then ethyl. I had a group, ethyl, because there's 2 carbons here. I had a couple students yesterday say they preferred kind of like the classic names. You're more than welcome to use that in this course. You can kind of name it however you want, as long as it is either systematic or IUPAC, or then you can use, of course, the classic names. These might be a little bit easier, especially if you guys have good memories, which I know most of you do. All right, I have 2 more. And then we'll look at halogen substituents, which is way easier than this. And then we'll check the time. We might finish this chapter today because the reactions of alkanes are very minimal. So guys, this should stand out to you right away. It looks like a T. It has 1, 2, 3, 4 carbons. So I know it's a butyl group, or an isomer of a butyl, and we would call this tert-butyl. Now, let's get the numbering down. 1, 2, 3, 4, 5, 6, 7. So this is definitely heptane. So we would call this tert-butyl heptane. But because it's a straight chain, well, I mean, it looks like a straight chain. It looks kind of bendy, doesn't it? But you need to tell me, where is that tert-butyl group on the chain? Is it on the 3rd carbon? Is it on the 4th carbon? And it is certainly on the 4th carbon here. So this would be 4 tert-butyl heptane. All right, last one. Now notice here, I didn't even bother with a systematic name. This is IUPAC as well. Like, this is the name. Tert-butyl is still accepted all over the world. And just remember, it looks like a T. Well, it actually looks like a lowercase t, doesn't it? Probably the easiest one to remember. So if you see a molecule that looks like a lowercase t, it's tert. Tert is a weird word, but remember, it stands for tertiary, because this carbon is bonded to 3 other carbons in the chain. We ignore this carbon. Okay, last one. So obviously this would be number 1. We always start at number 1. This, because it has 5, would be cyclopentane. Now, I see something in the chat there. Just let me finish this, and then I'll look at the question. We have 1. Well, okay, I'm not really going to number. I guess I could number it. 1, 2, 3, and then our fourth one up here. I'm not going to number that. I'm just going to count it as our fourth. So I know this is some substituent in the butyl group. It's an isomer of butane or butyl. So because the bond is on the second carbon here, what we would call the outside carbon, this is isobutyl. Okay, 4 carbons, isobutyl. So we would name this isobutyl cyclopentane. I mean, this looks crazy, but it's really not that bad. Now you'll notice I don't have a number here. I don't need to say 1, but you can if you want to. But I don't need to tell you that that's 1. If you were going to name this systematically, you would call this, well, I have 1, 2, 3. Let me change my color here. 1, 2, 3. So you would call this a propyl group with a methyl on the second carbon. So 2 in brackets. You don't really need the brackets if you don't want to, but because there's no other numbers in this. But 2-methylpropyl cyclopentane. Or just isobutyl cyclopentane, whatever you guys want to call it. Now let me read the chat here. No, I didn't say we didn't do tertiary. We don't do quaternary. I don't know if I'm even saying that right. We definitely do tertiary. We did tertiary in the lab. Lab number 2, you guys made a tert butyl chloride, like a tertiary butyl group attached to a chloride. So we definitely do tertiary. It is ISO. I see another question in the chat asking why this is not ISO. It is definitely ISO. Okay, does that make sense? I don't know if I understood the question, but it's definitely ISO. I have it written there. It is isobutyl. What are you talking about? It says right there, it's isobutyl. It's written right on the slide. Why not put 2? Why? Okay. We wouldn't put a 2. Okay, and now I understand the question. We wouldn't put a 2 because it's on the first carbon. It's right here. This is 2. It's not on the second carbon. It's on the first carbon. And because it's on the first carbon, just like in math class, you don't need to put the 1 there. Like, 1x in math, you would just say x. We don't need the 1. But it is definitely not on 2. Right? It's 1, 2, 3, 4, 5. Okay? Does that make sense? Let me know, because this is tricky. Like, this is definitely not the easiest thing in this course. Are you good, Naim? Are you still with us? Yes. Okay. Yes with a question mark. Ambiguous. You might be thinking, like, why aren't we putting a 2? There's a 2 here, but this 2 is for the systematic name. The 2 is showing me that I have a methyl group attached to a propyl group. Again, this is hard because I'm trying to teach you 2 ways to name things. But the 2 is only because the methyl group in the systematic name is attached to the second carbon. And if you guys don't like the systematic name, you can just stick with iso and sec and tertiary. Yeah, not the easiest thing, but I hope it's clear. Maybe. Okay. Well, Naim, if you have any questions as well, like after this class, we can do more examples, one-on-one or anybody else who wants to stick around. But we definitely don't put a 2 in front of the iso because it's on the first carbon. Okay. So again, if anybody wants more help with that topic, it's not the easiest. You're more than welcome to I have office hours. You can stick around after this class. Even, you can send me an email over the weekend and say you want to meet me Saturday afternoon. I mean, I can meet you. but I am going to move into the last section of this section. This is easy. You guys will like this. This is a nice kind of going back to what we started with. And if I have time, I'll finish chapter 2 with the reactions. I'm pretty sure the only reaction we really care about is combustion. But yeah. All right, 9M gets it. That's good. All right. So I haven't really done this yet. I'm actually following your course outline, which maybe I shouldn't be doing because personally, I would have done this at the beginning of this section, but the course outline doesn't have it like that. So this is really, really easy. We don't always need to just have substituents that are like methyl, ethyl, propyl. Substituents can also be other chemicals like oxygen and hydrogen, not hydrogen. Well, I mean, it could, well, hydrogen is not a substituent. Anyway, sorry. It could have oxygen, nitrogen, sulfur. It could be a halogen. Remember your halogens from chemistry 1120. I'm teaching 1120 now. That's group 17 or 7A. Halogens would be like fluorine, chlorine, bromine, iodine. These are really easy to name. They're very similar as naming just a regular methyl group or ethyl group. We take the longest carbon chain, we number from the end that is near any branch or substituents. Halogens have the same priorities as alkyl groups. So you would go in alphabetical order. There's no magic priority here. If there's more than one kind of halogen present, so if I had 2 chlorines, you would call it dichloro, 3 would be tri, and if there are several substituents, number them and list them in alphabetical order. So ethyl would be, well, no, actually chloro or bromo would typically come first in this case because of C or B. I hope you guys know your alphabet, right? So A, B, C, D, dot, 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 dot. Halogens, it's the same priority. There's nothing new here about constructing the name. The only thing you need to know is that, like, when we have a methane as our substituent, we change it to methyl. When you have ethane as a substituent, again, and I mean a group or a bond, a branch, geez, I can't talk today, we would call ethane ethyl. Well, if you have a fluorine, chlorine, bromine, or iodine, you just drop it and put an O at the end. So it would be fluoro, chloro, bromo, and this one's fun, iodo. Iodo, weird word to say. By changing the name slightly, it's really, it helps, for me, it helps it flow better. But really what's happening is you're indicating that it's a group or a branch on that chain. And we'll do some examples now in a second. Just gonna check the chat. Yeah, you have fluorine. I mean, fluorine is in toothpaste, chlorine is in swimming pools. I don't know where you would find bromine or iodine. Well, iodine would be in some medicines. All of these alone are quite toxic. Well, I know chlorine gas and bromine, like pure bromine, pure chlorine, are quite toxic. But when you mix them with other chemicals, they become quite safe or pretty safe. Oh, you mean a name of fluorine in the class? That's cool. I met a woman, another instructor recently, and her name was Amine. A-M-I-N-E. That's a group we talked about in chapter 1. So yeah, fluorine, amine. Some people got cool names. I've never met anybody named like carbon, but that would be pretty cool. Maybe that'll be a trend in the future. People will name their kids after elements. You guys could start it if you want. If you have children, you can name them like bromine or something. Be pretty cool. Cesium. Well, actually, some elements are actually named after people. So like Einsteinium is named after Albert Einstein. Cesium is named after Caesar, like Julius Caesar. There's more that I can't really remember right now, but a lot of the elements are named after people or places. Like there's a Californium and a Berkeleym. They're named after California and Berkeley University. So Some of the names are pretty cool. Anyways, let me go back. Let me do two examples. Sorry, let me just see what's coming up, and then I'll get you guys to do two examples. Maybe when I get here, maybe one of you guys could sketch this for me. But let me just show you two, and then you guys try two, and then we'll check the time. Okay. I love this example. This is a perfect example of something you might see on a test or a quiz or whatever, because it's, I'm not out to make your lives difficult. It's not too hard, but it's not, straightforward. It's not just heptane, because there are two chlorine groups. There's a couple things we need to consider here. And the first is our numbering. 1, 2, 3, 4, 5, 6, 7. So obviously this is heptane. The thing is though, I don't feel good about this numbering system. I think I could get my numbers lower. So let's start from the right side. 1, 2, 3. There we go. That's a lot lower. 4, 5, 6, 7. Okay. So on the 3 and the 4, you have what we call a chloro group. Just remember, because there are two of them, we call it dichloro. So, if you do this on a test, imagine you're doing this on a test or your final exam. Heptane, if you write me the word heptane, you get like half of a mark. If you write for me chloro, you get like maybe half of a mark, or 0.25. Basically, I think if you wrote dichloro, you would get the full marks, like 0.5. So you're already looking at a mark. And then for full marks, this might be marked at a 1.5 or maybe 2 at the most. I need your numbers. So heptane, you're going to get some marks. Dichloro, you'll get some marks. And then 3, 4, you'll get another set of marks. So, if you did this on a test and you said 3, 4 chloroheptane, you forgot the di, you'd still probably get like a 1 out of 1.5 or a 1.25 out of 1.5, something like that. So you'll always get part marks. And if you're not sure how to name something completely, write down what you do know. You should know that you have a 3 and a 4. You should know that you have heptane. So, just make sure you write something down. I'll try and give you marks if I can. So this is a good question for a test. Wink, wink. This is another good question for a test. The reason I really like the second question is because for full marks, I really would love to see alphabetical order here. So I'm numbering this. I know that I have bromo and I have chloro. Now the trick for this compound is that it's in a ring. And when you're using a ring, you can number any way you want. Sorry, well, no, I said that completely wrong. You can start numbering technically anywhere, but to get the name right, to get the perfect IUPAC or systematic name, I would start at the lowest alphabetical order. And I mean, this is a beautiful question. There's so many little things to keep in mind here. So I want to call bromine carbon number 1. And I want to call this carbon number 1 because B is first in our alphabet. A, B, C. Okay, now you have two options. You can go clockwise, and I don't like the look of that, right? This name that I have written would be 1 bromo, 5 chloro. Ugh, I don't like that. When I could just go this way. 1, 2, I get my lowest possible numbers. Now again, you guys know I'm not picky. I'm not going to go too crazy with this, but I mean, if you want to be perfect, you want to get absolutely perfect 100%, start at the BR because it's bromo, and then go this way. Go counterclockwise. So this would be 1 bromo, 2 chloro. Notice there's no space here. This is just all one word. 1 bromo, 2 chloro, cyclopentane. Now, I don't know, some of you guys are pretty smart, and some of you guys have maybe even done this before, but if you went back a month ago and looked at this and thought that you would be able to name this. Like I just think about my last semester I taught this. Some students were like, you know, if we saw this a month ago, I never thought I could have like ever seen this chemical name. Like in 1120 and 1121, you're naming things like sodium chloride or potassium nitrate. But then you get into this course and you get like 1-bromo, 2-chlorocyclopentane, or going backwards like isobutyl cyclopentane. You're getting some interesting names here, but it's easy. It's systematic, meaning we break the molecule down into its parts and we can do it. And yeah, I mean, like to me, before I started chemistry, this would have been like a whole other language to me. Like, I mean, and I'm an English speaker natively, and this is just what the heck, right? I never would have ever expected to know this, but with a bit of practice, it makes sense. You really just need to know your substituent names and your straight chain carbon names, meaning like methane, ethane, propane, butane. If you know that and your substituents, you're good. All right, so I'm going to stop talking. I'm going to put myself on mute, and I'm also going to pause the recording. And I'm going to give you guys 2 minutes. And if anybody wants to write the answer in here, feel free to do so. You can even write the name here if you want to. If you don't want to write anything, don't worry. But I'll be back in 2 minutes, and we'll go through the answer, and then we'll pretty much be finished for today. All right, so I'll be back in 2 minutes. Okay, so here's my plan. It's 10 after 1, and it's a wonderful Thursday. So I'll put these 2 answers up, and then I'll introduce this section. There's really, I mean, I could finish it today. No, I don't think I could. But we'll finish chapter 2 on, when do I have you guys next? I guess Monday. I think I have you on Monday. And then we'll get into chapter 3 on Monday or whenever your next class is. Chapter 3, guys, is exactly like chapter 1, or sorry, is exactly like chapter 2, except we're going to do alkenes and alkynes, and we'll learn how to name them, and we'll learn how to write chemical reactions or predict the products of chemical reactions. All right. So yeah, did anybody want to sketch this, or do you want me to do it? This one here on the left. No big deal if nobody wants to. I'll check the chat. If nobody agrees to in the chat, I'm going to do it. I will proceed. Okay, here we go. Okay, start with your parent and your suffix. So remember the parent and the suffix. The suffix is ane, which means this is an alkane. And I'm stressing this because on the next class, or in the next class, we're not going to deal with alkanes. We're going to try alkenes and alkynes. So I know that this is just pentane. So 1, 2, 3, 4, 5. I love pentane. It looks like a big N. All right, I'm a number left to right person. So I'm going to change my color here for 1 quick second. 1, 2, 3, 4, 5. If any of you guys numbered this the other way, meaning you went from right to left, not a problem. So on the first carbon, whoops, I didn't mean that. I will have a bromine. And on the second carbon, I will have a bromine. This is 1,2-dibromo. Now notice, guys, that this doesn't make my carbon chain any longer like a carbon chain. This is still just a bromo group. It doesn't make, I'm not changing this to hexane. It's still pentane because this is my last carbon or my first carbon. And then on the third one, I have a methyl group. There you go. Now, if yours looks a little different, maybe you numbered it left to right, maybe you drew your bromine like straight down, like maybe you did something like this, that's fine. It doesn't matter, okay? I think technically it would look like this, but doesn't matter. I'm not that picky. I'm not going to worry too much about bond angles and things like that. If like the key word here is sketch, and the word sketch in English just means like, give me your best interpretation of this. I need to see the right number of elements, of course, but I don't care about bond angles. Not for this course. All right, write the name for this molecule. I'm going to erase this box so I have lots of room. This is a good one. Okay, first things first, when I see chlorine and fluorine, I want to think about alphabetical order. So A, B, C, D, E, F. Obviously, C comes first. So I'm going to try to number this so chlorine comes first and pick my longest chain. So 1, 2, 3, 4, 5, 6, 7. Pretty easy. So I'm going to have a chloro. Whoops. I'm going to have a fluoro. Notice that it's F-L-U-O-R-O. I do not care if you don't spell that right. Don't worry about spelling. I have a lot of students write fluoro like this, and that's fine. It's not right, but I don't care. And on the fourth carbon, we have ethyl. Just a warning though, if any of you move on to do degree programs or you move on to do, if maybe you go to another university to study like chemistry, you definitely want to spell this correctly because my professors weren't that generous with their marks, I tell you. Okay. So let's go. I'm going to go in alphabetical order. This is really interesting because C, E, F. This is a pretty tricky one in the sense that you need to make sure you know your alphabetical order. So this would be 3 chloro, and then ethyl comes next, 4 ethyl, 5 fluoro, and then heptane. That's all one word. I didn't mean to put a space there. Heptane because there's 7 carbons. Cool. Is that okay, everybody? This one is tough. Oops. This one is tough. And when I say tough, some of you might be sitting there thinking, oh, well, that's really easy. And that's a good thing because that's honestly about as hard as they get. All right, so guys, it's 1:15. I'm going to stop it there today. That's enough talking for me. So in the next class, we will finish chapter 2 and we'll start chapter 3. So are there any questions before I go? I'll hit stop record now. So this will go up on YouTube today. And yeah, any questions, let me know. Other than that, have a fantastic and safe weekend.